All right, so today we are going way beyond the basics, way beyond just planets orbiting the sun, because we are going deep on the formation of our solar system. You guys sent in some really interesting stuff, and it looks like you're ready to get into like the awesome specifics, the weird and wonderful. And trust me, when it comes to the cosmos, we've got that in spades.
Absolutely. I mean, talk about a glow up, right? We're talking about going from this totally chaotic cloud of gas and dust to like the elegant order of planets and moons and asteroids, all held together by, this delicate gravitational dance.
It really is wild if you think about it. So where do we even begin with this?
Well, we got to rewind the cosmic clock like billions of years. Imagine this, like just this vast cloud of gas and dust just kind of hanging out in space, and it's like honestly kind of boring, and then bam, a shock wave, probably from a supernova nearby, hits this cloud like a cosmic alarm clock.
Okay, so a supernova shockwave. Now that's how you wake up the universe. What happens next? Does everything just explode outwards?
Not quite an explosion, more like I guess you could say like a cosmic mosh pit that just get a whole lot more organized. That shock wave kind of triggers this chain reaction. Suddenly, all this gas and dust that was just minding its own business is bumping into other particles, and they're starting to stick together. And gravity just takes over, pulling in more and more material.
Okay, so we've gone from 0 to 60 in a few cosmic seconds. Things are getting denser, hotter, and this is where our sun decides to make an appearance, right?
Exactly. And the sun is not just bringing the light and heat to the party, it's also throwing out this solar wind, which is this crazy powerful stream of charged particles just pushing outward. Imagine like, I don't know, a leaf blower, but on a cosmic scale, just clearing out a very messy garage. That's basically the solar wind shaping those early days of our solar system.
So not just the life of the party, but also the one who cleans up after, huh? But how do we go from this swirling disk of leftovers to actual planets, each with their own unique thing going on?
Well, it's all about location, location, location. You see, in that inner ring, close to the sun, it's like standing on a star, unbelievably hot. And only the toughest stuff could handle that heat.
Right, get too close to the bonfire, you get burned. So that explains the inner planets, Mercury, Venus, Earth, and Mars, all those tough, rocky worlds. But then you've got the outer planets, the gas giants. Those are a totally different breed. What's the story there?
Think about it this way. You get further from the bonfire, the heat's not as bad. It might even be kind of chilly, right? The outer region was way cooler, and that's key because it meant that gases, even ice, could actually condense. And that set the stage for those gas giants, Jupiter, Saturn, Uranus, Neptune.
And because they were working with all that lighter material, they were able to really pack on the pounds. I mean, they're huge compared to the inner planets.
You got it. With all that hydrogen and helium to feed on, they just became the heavyweights of our solar system, like cosmic vacuum cleaners just sucking up all that lighter material.
Okay, so we've got the broad strokes, a nebula, a shock wave, planets finding their place in this delicate dance of temperature and gravity. But I want to get into the specifics. You've got some seriously mind-blowing details about each of the planets themselves, right?
Oh, absolutely. This is where it gets fun.
So give it to me straight.
Yeah.
What's the most surprising thing about each planet? What would make someone say, wait, seriously?
All right, let's start with Mercury. Everyone just pictures it as this like scorching hot rock, right?
Oh, well, yeah, it's basically got front row seats to the sun.
Great. But get this, NASA's Messenger spacecraft, it actually found evidence of water ice at Mercury's North Pole.
Hold on, ice. On the closest planet to the sun. That's like cosmic irony or something.
It is kind of wild, right? But it kind of makes sense when you think about it. That ice is tucked away in these super deep craters that are always in shadow. They're like cosmic freezers, keeping that ice nice and stable, even though it's crazy hot, just a hop, skip, and a jump away.
So Mercury's got a bit of a hidden layer, like a cosmic sundae with a surprise at the bottom.
Yeah.
Okay, what about Venus? Now, that's a planet with a serious PR problem.
Venus is a whole other ball game. I mean, first of all, it actually spins in the opposite direction from most planets.
Are you serious? So on Venus, the sun sets in the east. You're messing with my head.
Oh, and it gets even better. A day on Venus is actually longer than a year on Venus.
Okay, now I know you're messing with me. You're saying it takes longer for Venus to spin around once than it does to go all the way around the sun. That's like saying your birthday comes twice before you finish one spin.
You got it. Venus does not play by the rules.
Huh.
And speaking of planets that like to keep things interesting, let's move on to Mars. Everyone's always buzzing about the possibility of life there.
Yeah, who doesn't love a good Martian mystery, right?
Whether or not we find little green men is still up for debate. But you know what we do know? Mars has these massive sheets of water ice right under the surface. We're talking some of them the size of California.
Whoa, that's a lot of ice. Guess future Martians won't be going thirsty anytime soon. Okay, I gotta ask about those gas giants, though. They've got to have some seriously mind-blowing stuff hidden in all that gas.
Oh, for sure. Take Jupiter, for example, specifically that great red spot that everyone's seen pictures of. Did you know that storm is bigger than Earth? And it's been going strong for centuries.
Centuries? We're talking about a storm with more stamina than, like, most empires. That's insane. All right, what about Saturn? Besides the look at my amazing rings thing, what's going on with that planet?
Get this. Saturn is actually less dense than water.
Wait, hold on. If we had a bathtub big enough, Saturn would float.
Hypothetically, yeah. Though I don't even want to think about the bathtub bill for that one. And speaking of weird rotations, Uranus wins the cosmic gold medal.
Oh, Uranus, always the overachiever. What's it up to now?
It spins on its side, like a ball rolling across the floor, not like a top.
You're kidding. What could make a planet tilt like that?
Yeah.
It's like it got in a cosmic fender bender or something.
That's actually a pretty good analogy. Astronomers think that billions of years ago, way back when the solar system was young, something huge slammed into Uranus and knocked it for a loop. Literally.
Talk about leaving a mark. Okay, speaking of cosmic impacts, Neptune has a pretty interesting backstory too, doesn't it?
It does. You see, Neptune was the first planet that was discovered by math, not by looking through a telescope.
By math.
Yep. Astronomers noticed that Uranus wasn't quite where it was supposed to be in its orbit, like something was messing with its gravitational groove.
Okay, so it's like finding a mysterious footprint and trying to figure out who it belongs to, but with planets.
Exactly. They basically did some calculations, figured out where another planet would have to be to create that gravitational effect, and boom, they found Neptune hiding in plain sight.
That is wild. Okay, we've covered the 8 planets, but we both know our solar system isn't done throwing curveballs, right?
Uh-huh.
Those articles you sent, they mentioned other stuff out there too. Asteroids, comets.
Yeah, it's definitely not just planets out there.
So it's not just planets, huh? What else is out there in our cosmic neighborhood?
Well, first you've got the asteroid belt. It's this huge ring of rocky leftovers between Mars and Jupiter, basically a cosmic shooting gallery.
Sounds a little dangerous for any spacecraft that wanders too close.
Yeah, it can be a bit dicey. And then even further out, past Neptune, things get really interesting because that's where you get to the Kuiper belt.
Ah, yes, the Kuiper belt. Home to everyone's favorite dwarf planet, Pluto.
And a bunch of other dwarf planets and icy objects, too. It's like a cosmic deep freezer out there, full of remnants from the early days of the solar system.
So like a time capsule, giving us a glimpse into the solar system's baby pictures. That's incredible.
It really is. And if we keep going even further out, like to the very edge of the sun's influence, that's where we find the Oort cloud.
Okay, the Oort cloud. Sounds a little ominous. What exactly is that?
Think of it as the source of all those comets that we see streaking across the sky.
And the Oort cloud.
Yeah.
So those comets all come from the Oort cloud.
Most likely, yeah. They just drift around in this distant cloud until something, maybe the gravity of a passing star, gives them a little nudge and sends them hurtling towards the sun.
Like cosmic snowballs just waiting to be thrown. Wow. Okay, so we've got the asteroid belt, the Kuiper belt, the Oort cloud, all this stuff out there just hanging out, orbiting the sun. It's kind of amazing how much is going on in our solar system that we never even see.
Right, and that's what's so cool about astronomy. Every time we think we've got it all figured out, we discover something new that totally changes our understanding of how it all works.
It's definitely a humbling experience. Makes all our little problems down here seem kind of insignificant, huh?
I know what you mean. There's a certain sense of peace that comes from contemplating the vastness of the universe.
It really puts things in perspective, doesn't it? But you know what else I find amazing? Even with all we've learned about the solar system, there are still so many unanswered questions, so many mysteries.
Oh, yeah, absolutely. Like we were talking about before, Planet 9 is still out there somewhere, potentially, and that's just one example. There's still so much we don't know about those outer regions of the solar system, about how exactly planets are formed, about what it's actually like on those other worlds. It's incredible to think about.
Seriously, who knows what else is lurking out there in the darkness? Maybe other Planet 9s. Or maybe even whole new categories of celestial objects that we haven't even imagined yet. Kind of exciting and terrifying all at once.
You hit the nail on the head. And it just goes to show how important it is that we keep exploring, keep pushing the boundaries of what we think is possible with new telescopes, new missions, new ways of looking at the universe. We've got so much more to learn.
I'm with you there. Something that really stood out to me during this deep dive was just how dynamic our solar system is. I feel like we tend to picture it as this kind of static, unchanging thing, but as anything but.
You're right, it really is. It's like this incredible cosmic dance with planets moving in their orbits, moons spinning around them, asteroids crashing into each other, comets flying through space. And it's all driven by these powerful forces of gravity and momentum playing out over billions and billions of years.
It's mind-blowing when you stop and actually think about it. And to think, every bit of it, the sun, the planets, even those distant icy comets, all of it came from that one original cloud of gas and dust. It's like, I don't know, the universe just exhaled and our whole solar system was born.
That's a beautiful way to put it, and it really highlights how connected everything is in the grand scheme of things. I mean, the atoms that make up our bodies, the air we breathe, the ground we walk on, it all came from stars, just like the stuff that makes up our solar system.
Whoa. I never thought about it like that before. But it's true. We really are just children of the stars.
Exactly. And that connection to something so much bigger than ourselves, that sense of wonder and awe, those are feelings we should always hold on to.
Well said. After this deep dive, I feel like I have a whole new appreciation for just how amazing, how complex, and how mysterious our solar system really is. It's incredible.
It's been great exploring all this with you.
The pleasure was all mine. And to everyone listening, thank you so much for joining us for this incredible journey. We hope you learned something new, felt that spark of curiosity, and maybe even looked up at the night sky with a fresh sense of wonder. Until next time, keep exploring.